Well, hello everyone. Thanks for sticking around to the bitter end here. I am Tim Payne. I'm an engineer with CAMECA. I've been first Imago, then CAMECA for 18 years now. I started in 2002. I started as a electrical engineer actually, and helped design some of the early electronics for our first atom probes that we sold, and then. Now that the electronics are fairly mature, I have transitioned into the software world, and that's been probably about 10 years now. And then when we started the big rewrite of IVAS, they put me in charge for some reason of the architecture of the new software. So it's a little bit about me, and let's get started. So Peter, you basically gave the exact same intro that I was going to give. Which is why we're talking about free software here. What is a commercial company doing? Well, the thing is, we sell atom probes, and I would venture to say most of you are getting your atom probe data from a CAMECA atom probe. So, and the software comes with it, so you probably have a copy of IVAS, and if you don't have APSuite, you probably soon will. So, my job here is to tell you a little bit about what we're doing with APSuite, and talk about our strategy with APSuite, what we're doing, and talk about, and then I'll give you a demo at the end, show you all the things that I find are really interesting and that are new to APSuite. So APS is what we call it internally. It's Atom Probe Suite. It's really the successor to IVAS, and what we're doing is we spent probably 4 years now basically starting over. IVAS was started very early in our company's history, and it acquired a lot of what we call technical debt, which is we used software packages and things like Java 3D that just aren't being supported as well, and then more and more as more and more time goes on, it's harder and harder to support those things. We really had to make a kind of a clean break, and it meant that there's kind of a lag between when all you as our customers saw updates. So you kind of IVAS 3 has been a little bit of a stasis holding pattern for a few years now, as we've been totally shifted over to working on Atom Probe Suite. And Atom Probe Suite also is an effort to unify all these different software packages that we had before. So Dave, I stole the slide from you. This is basically, we used to have, hopefully you can see my mouse here, we had ACC, which is the program that acquired the data as a control software. We had Davis, which was a separate Java program that did live real-time visualization of the data while it's being collected. And we had a separate database tool called ISDB, and then we had another tool called IVAS, which I'm sure you're familiar with. And so we're trying to integrate all these tools together under one shell, which is what it's called. We're calling this Atom Probe Suite, and right now we have pretty much everything in the Atom Probe Suite except for the control software, and that'll be the last thing to come. It's probably you get another couple years down the road before we get that incorporated. So a little bit about the APS history. So we initially released a 6.0 version almost exactly a year ago. That was for analysis only. It didn't include any acquisition stuff. So some customers got that kind of like an early peek at APSuite there. And then this summer we released 6.01, which rolled in the acquisition features. So that's Davis and live reconstruction. That came out this summer, and more customers got that. And at the end of this year or early next year, we're going to release 6.1, which is basically continuing a continuous improvement of what we started in 6.0. And then basically from there on, we're going to continue sort of annual releases. One thing I wanted to point out is that right now we still have the the free version of IVAS Lite. That's still the IVAS 3 software. So right now, if you request IVAS Lite, you'll get IVAS 3. 6.2 software, which is going to be out in about 1 year. So let's see, a little bit more than a year. That we will be starting to ship APSuite Lite, which will be a free version of APSuite. And everything I'm talking about today in this PowerPoint, at least, will be included with the free version. Some of the stuff I demo later will not necessarily be included in the free version, but I can enumerate that for you if you like. So this is my philosophy, and hopefully CAMECA will embrace as well. This is my philosophy and how we deal with kind of the user-created software, so the stuff that Peter and Marcus and all you have been showing. Lots, for years, users have been writing their own software to do, very specific add and probe and data analysis for their things. And we've tried over the years to try and integrate some of those things into IVAS, but a lot of these things were sort of very, very specialized. Maybe they had a lot of parameters, and it really didn't work very well. And also, there's lots of people, as Peter has shown, are doing the same thing. So everyone has written a pause reader, everyone's written ePause reader and writer. People have done their own access surfacing code in multiple languages in different ways all across the world. So we're hoping that we can sort of stop that sort of duplication of efforts and start sharing some of these tools. So we're not trying to rewrite any of those tools. We want to facilitate a platform where people can plug into our software and make use of the things that we're good at, which is making raw add and probe data from a machine, and now with APSuite, visualizing add and probe data and analyses, and then I don't want to say offloading some of the work, but bringing in some of the work that you as a community have done into our software, so that we can provide more analysis features for the community than we could possibly do ourselves. So I wanted to talk a little bit about file formats, because that's really sort of that's the beginning of what you do when you're doing add and probe data analysis, especially when you're not using our tools. So you may be familiar with our older formats, RRAW and RHIT. Those we actually don't use anymore. We've now migrated into STR and HITS files, which can be written much faster. It takes a lot less CPU power. These R files, these root files, are compressed, and the larger they get, the longer it takes to basically rewrite them with compression. And if you have a large run, basically it consumed your entire CPU trying to write these. So we just went away from those. And then after you've done reconstruction, there are some files you're also familiar with, pause files, which is big endian floating point, binary file, no header, really simple XYZ, and master charge. And then I don't know if we introduced this or somebody else did, the ePause format, which is like pause, but it's 11 fields wide and includes XYZ master charge and time of flight and voltage at the specimen, voltage at the from the pulsar, and some other fields as well. ATO is the FlexTap format, and our new format that we introduced with APSuite 6 is called APT, and I'll be talking about that next. Why do we go to APT instead of sticking with pause? Well, one, there's a few reasons. One is that it makes sense to use big endian anymore. We were converting back and forth many times. And we wanted to have a format that had an arbitrary number of columns instead of having exactly 4 or exactly 11 and nothing in between. The new format lets you have as many as you want. Also, we want to be able to have metadata included with the APT file, so you can include things like ranges or experimental details. Also, it's very important when we talk about the initiative for open data when you publish. You want to have all that metadata in one file, and you can hash the entire file and have everything ready there for you. Also, I wanted to support sparse data. So let's say you wanted to partition your data into two phases, phases 1 and 2. Well, it often doesn't make sense to write a 1 or a 2 for every ion in the entire set. Maybe you can just say, well, the first 100,000 ions in the set are 1, and the second million are in phase 2. And that saves a lot of data without having to write the entire column. And then also with APT, I wanted to make sure when I wrote this new file format is that you didn't require any third-party libraries to read or write. And I looked really strongly at HDF5 based on Marcus's and other people's recommendations, and found that in the end, it was kind of a heavyweight library to drag around anytime you wanted to like write a really simple script to read and or write a file. APT is a little more complicated than a pause, but you can still, if you want, you can kind of ignore the format and just say, just seek to byte 540 and start reading the pause data like you normally would. So sorry, HDF5, but we will be providing converters to and from formats and or letting the community write plugins that convert to and from APT formats and allow that. Basically, like you can add options to your import menu inside APSuite. So sorry, HDF5 again, but we will be supporting it in sort of a off the side import way. Anyway, a little bit more details about the APT file. The full spec is in our user guide, but basically, I'll talk about it really quickly. There's a header at the beginning of every beginning of the file that includes a little bit of information, but really, if you want to have more information, those go into sections. So after the header, you have sections, and each section is just one right after another. The section length is encoded in the section header. So if you wanted to jump through the sections, you just jump based on the section size. The sections can be, if you want, they can be just a text field. So if you wanted to insert a really long comment, you could have a new section called comment, and it just has this, say, 10 kilobytes of text, and then it can go anywhere in the file. The order of the sections is not important as far as APSuite is concerned. So I won't dwell on this too much longer. Some of the sections that are available right now, actually I pasted this from the code. When you're doing your reconstruction, as well as having your X, Y, Z, and master charge in your APT file, you can also choose one or more of these other columns that are available. So these are things that have been asked for a long time. For instance, laser positions, various corrections for reconstruction, detector coordinates, multiplicity, all that good stuff. Detector coordinates, X, Y. I think it pretty much has everything that people want. Let's continue on here. If you're wondering where to find this in APSuite, in the reconstruction view, you have to scroll down, and then there's this new section here, APT sections, and you can just check the boxes for the columns you want to add to your file. This first thing here, section name, that's the name encoded in the file. So if you're writing a reader yourself, this is the string that you would look for in the file. And then the right-hand column here is kind of the human readable section name. Also included with the new software. This isn't out yet, but there's now an APT File Inspector included with APSuite. So if you have an arbitrary APT file, you can open it in this inspector and look at all the different sections, and it'll tell you exactly what's in all those sections. I can show you how to get to that when I do the live demo. All right. Also coming soon, and I don't have any pictures, unfortunately, but this is, I think, one of the coolest features is that when you have these arbitrary columns of data in your file, your APT file, we'll be able to visualize those, even if it's a column we're not aware of. So basically, if it's an integer type, you get to choose what color you want for each integer, or if it's an integer or floating point type, you can color based on a heat map or a color map. So, and that map is editable by you. And then instead of displaying in the 3D view of IVAS, instead of coloring it by the ion type, you can color it by your column in your APT file. So if you wanted to color them by multiplicity, for instance, you could say, well, if it's the first hit, you can make it red. If it's the second hit, you can make it blue, for instance. Or instead of, let's say you did some cluster finding and you have a different integer for each cluster, and so you have a new column called cluster ID. You can color your clusters based on their ID. The way that IVAS3 did it was sort of workaround, which is it wrote out a new POS file that replaced the master charge field with the cluster ID, and then had a new range, a special range file that colored appropriately. So APSuite 6.1 will have the ability to kind of natively color based on the cluster ID using that column. Now, one thing I haven't mentioned yet is that when you're creating these columns, you can create them virtually, meaning they're just in memory, and when you close APSuite, they go away. You have to recreate them later, or you can actually write them to the file. So if you have something that's really easy to calculate, you don't have to waste all the disk space to write that column. You can generate it on the fly using our custom analyses, which are coming up here. So we're calling our analysis tree plugin the custom analysis. So you insert a custom analysis into your analysis tree just the same way you would insert any other analysis type, like a 1D composition or a bulk composition analysis. So you right click on your tree, you can do it at the top level, or you can do it from an ROI. So if you wanted to analyze just the ions inside a cube, for instance, you'd right click on the cube, go down to custom analysis, and then you get a menu which is automatically populated by analyses that are available from DLLs that are populated or are put into a certain directory. So there's some examples that come with APSuite 6.0. That's the 6.0 examples are listed here. We are going to publish even more examples. These examples or these custom analyses aren't tied to any specific version. The interface is quite simple, and so it shouldn't evolve much over time because it is very simple. And so we can kind of publish these to the web, to GitHub, and this is all a work in progress. But the idea is that we'll be able to have different analyses here, and then users can make them as well. So when you make an analysis, a custom analysis module or a custom analysis script, you could say, it has access to all the data in the tree. So if you are at the top level, you get all the ions from the top level. So all the ions in your data set. If you put your custom analysis on the ROI, well, you get all the ions from that ROI. And the data is automatically filtered for you, but it's as wide as the APT data is. So often it'll be just your position XYZ and master charge and ion type. But if you have extra columns, you'll also get those. filtered and they'll match up with your ions. The custom analysis can do, it's really just a piece of software. It can do anything you want. It can call into external tools like Python scripts or command lines, or call into other modules. Really, since it's just a piece of code, it can do anything you want. And I'm really excited to see what the community can come up with there. Let's see. Also, I'm forgetting if I have a slide specifically for this, but the custom analysis also has an output, so it acts like an ROI itself. So if you wanted to write a custom filter in your analysis module that used, for example, some of this arbitrary data that is in the file, you could filter, you make your new special type of ROI that filtered based on multiplicity, for instance, and then you could add other, and then it just goes in the tree, just like any other ROI, and you could add other analyses to that custom analysis node, just like you would any other ROI, and you could sort of stack these various types of things on top of each other. So let's continue. So when you have a custom analysis, there's an automatically generated property grid UI from for properties that you have in your analysis. These properties are, you can have defaults that are automatically saved with the analysis when you save your analysis. And this property grid is just automatically generated for you. It supports all sorts of different data types. And you're probably familiar with this from IBAS 3. It's a similar concept in a lot of different software packages. And then there is, on the right side, is the output pane. And the output pane is generated through an interface called this view builder. And you can have various types of output that are rendered here for you in your UI, your analysis UI. You can have this raw text like a log, or just a console output like you would from a command line. You can have tabular data like I'm showing here. Also, you can create two-dimensional plots. There's some examples here. This is obviously like a line, a series. And then here is a heat map, kind of like it has a 2D plot with a third dimension. In this case, it's a Saxy plot, and I'll show you that live as well. You can also do a new 3D display of your choosing. You can have point data or surfaces, or even sort of primitive types like spheres and cones and arrows, that sort of thing. It's all available through that view builder interface that we're giving you. There's also, let's see, so the source code is in the source code for the examples that are built into APSuite 601. That source code is included as a zip file, as well as the built versions, the DLL. It's built using Visual Studio 2017 or greater. You can use the free version. It's totally fine. Visual Studio Express. You don't have to pay for anything. Before you ask, we don't have documentation yet, but fortunately, I'm sorry, fortunately Visual Studio has, with C# and .NET, it allows you to look at the API right inside the IDE, and you basically can inspect it, and I'll show you exactly how that works in a little bit here. In fact, maybe now would be a good time to poke at this. So I'm going to switch over here to exactly what I just showed you, which is this is the source code. So I opened up the zip file that comes with APSuite 601, and it is a C# project. It has basically approximately one file per analysis option that you get. There's this custom analysis module is C# is the entry point, or the kind of the starting point for the custom analysis, and that you use this command register to add to add items to the custom analysis list, and then these point to the classes. And all you have to do is implement this thing called iModule. If you want to know what iModule is in Visual Studio, you can always right-click and say go to definition, or hit F12. And I guess I have ReSharper, but it will look the same no matter what you do, and it tells you exactly what things you have to implement yourself in a custom module to be recognized by APSuite. And I'll show you the Saxy diagram code quickly here. Each menu item has to implement basically a couple things. So it's custom analysis, and the option type is the thing you need to derive from in your analysis class. Again, if I hit F12 here, like you can see what custom analysis is, and there's just one function that gets implemented, and it's just this run function. And when you call run on, or when you open up your menu item, run gets called for you, and run is passed the parent node in your tree. It's passed your options that were defined by that property view, and it's passed this view builder objects. And again, I can look at what's a view builder object. Well, view builder gives you options for adding a table, adding text, adding chart 2 or 3D, and also adding a 2D histogram, which is like that Saxy plot. So if I move back using my back button, or using this button in the upper left here, I can get back to my code, and you can see that my run function here is looking at the ion data, which ion data is the main data source. That's the APT object, basically. That's what reads the APT data. And here I'm looking at section info, making sure that I have the right sections to build this Saxy plot, and then I go through building it, which is a function that was written by a GPM, AQGPM, and really it's going through each ion and building. So here's where it goes through, and it checks the multiplicity and adds events to the internal data structures here. So I can show you how this works in real life here in APSuite. So quickly, I can pick any reconstruction. I'll pick this one right here. So I double click there, it adds it to my workspace, and I create an analysis tree by double clicking or right clicking and say create analysis tree. And then I have my data here, and I can right click, go down to custom analysis, pick my Saxy diagram here, and it's telling me that I don't have the right data in my APT file. And that's because I didn't choose multiplicity when I created that reconstruction. So, all right, well, I'll go back to Data Navigator here and open it in the reconstruction wizard. And then I can just zip over to the spot where I saved the file, and we'll just redo this quick. So, unfortunately not, I don't think in 6.1, but in the future, we'll be able to get this data, get these extra data columns on the fly. Right now, unfortunately, you have to do it from the wizard here. So this is where I scroll down to APT sections, and I can add on the multiplicity section and save this as with multis. So I'm not sure how many of you have if, I don't know if this is your first time seeing APSuite, but the wizard should look quite familiar to you, as we basically copied the layout of the IVAS3 wizard. So it has your 7 steps, and you create a preview. Oh no. I'm running a brand new debug version, so I may be in a bad spot here where I don't have the right things. Well, we'll come back to this later. So let me continue here with the presentation. All right, so I wanted to talk a little bit about what's coming with this 6.1 release that's coming out right around the new year. So this is giving us specifically these goals are related to this user analysis stuff. There's other things in 6.1, but these things are specifically related to what you as advanced users are interested in. So you're gonna get access to more analysis data basically from outside, either from inside APSuite using these custom analyses, or through export things. So for instance, you can export isosurfaces in a I'm forgetting the exact format we're using for that. But it's like an industry standard mesh format, as opposed to trying to
STL maybe.
STL, is that what we said?
Is it STL?
Yeah, I think STL sounds right. So like an industry standard format, as opposed to having to extract the isosurface data from VRML. I think that's what people have been doing in the past.
Yeah, either that, or we wrote a script to get it out using the JSON interface.
Okay, yeah. Also, access to the grid, so that's a voxel grid of concentration data or whatever you choose, and basically, hopefully anything you want, and also, as I showed already, that entire list of various columns will be available in 6.1. Coming also is this visualization of arbitrary data that I've already talked about. So being able to color, not just based on ion type. We're also making available, so I talked about this a little bit, which is you can generate like your own filtered data from a custom analysis node. And one thing that I think might be quite interesting to some people is you could also generate totally fake data from a custom analysis node. So if you wanted to do little mini simulations based on things right inside of your analysis tree, you could do that. Also, we're going to give you the ability to, correct me if I'm wrong, Dave, is this still coming in 6.1? The ability to...
as long as you can get it done in time.
Yes. The ability to also have a similar plugin for the reconstruction steps as well. So that this is not going to be, so the custom analysis stuff will be available in APSuite Lite when that comes out. When I talk about reconstruction features, this is one of the things that is not in the Lite version, but you'll be able to have scripts that access sort of the wizard steps. So if you wanted to automate choosing ranges, or if you wanted to automate, but you didn't want to automate anything else, or you wanted to be able to run experiments where you change the image compression factor 10 different times and compare the results, you can do that with reconstruction scripts. And also, we are going to launch our online custom analysis repository with 6.1. So that's where it'll be in GitHub, I assume, and people will be able to have give us pull requests, or you can also from within APSuite link to any Git repository at all, and you can like your own repositories or somebody else's repositories, and be able to kind of automatically get and hopefully build, if you have the right tools installed, code from the web. All right, so I want to go back to the APSuite demo and show you some of the things that I'm really excited about in APSuite. And unfortunately, I apologize, the demo of the Saxi plot didn't work. All right, I'm going to close a couple of these things here. So let's say, you guys can still hear me, right?
Yes.
Yes, okay, thank you. My headset made some beeps that I don't recognize. So let's say we have this data set and we want to make an ISO surface. So the ISO surface interface has changed quite a bit in the recent couple of months. And I wanted to highlight sort of how it works. So let's make a new ISO surface here. Let's make it an oxygen concentration. Let's turn off my ions so I can see my my ISO surface a little bit better. Here we go. No, that looks pretty good, right? Well, so we have, I'm showing in this interface analysis panel here, all the interfaces or all the kind of discrete surfaces that were created when I did this ISO surface generation. And let's say I want to do some analyses based on these surfaces. And I want to use these as a way to segment my data. Well, these two surfaces I don't really care about. So what I can do, because they're really, in fact, you can't even see them; they're so small. If I turn these off, I'm not even sure I can see them in the data. Let's see here. No, not really. So I don't want those. So what I can do is I can make a filter here that says I only want surfaces that have polygons greater than 1,000. And now I'll turn them back on so I can see them. You can now I can make a subgroup that uses these filtered surfaces. Okay, and so it makes a subgroup, and now I could add some analyses based on this ISO surface. But let's say now I want to go back and I want to change my ISO value. All right, I want to oops, there's two dialogues here. Properties. In the past, when you would change this, it wouldn't update your interface groups at all. You'd have to make them again. They were sort of disjoint. Now, if I change my value here, you'll see that my group is turned orange, and that means I need to update it. And then when I've updated it, because I used an algorithm, I used a filter to pick my surfaces. The same surfaces are still chosen here, and ignore the smaller ones, okay? I can even use this to go to a different data set that maybe is like it's the exact same sample type, but a different actual sample, a different actual experiment, and I can copy this this analysis over, and it will use this algorithm that I've chosen to choose the surfaces in the new data set as well. And And I think it's a very powerful way to kind of instead of hard coding these surfaces when they're created, they're now algorithmically based, and you can even go further if you like. There's a new feature here where there's a hidden column. If I show this column chooser, there's this thing called expression. When I add this expression column, I can pull up this thing called the expression editor, and I can add actual formulas to this table of interfaces. So let's say I only care about interfaces of a certain shape. This actually isn't a great example of a data set, but let's say I want things where so these extent XYZ are actually maybe I want to look at things where the extent in Y is, a double click here adds it to the expression editor, and I want to say the extent in Y is greater than the extent in Z. I hit OK here, and now I have a new value that's in this this column. It's either 1 or a 0 for this Boolean formula here, and now I could add a new filter. This isn't a great example because they're all the same type. That I could say only the types. So I don't know why it's showing that. I can. Not sure why it's not working here. Sorry about that. I can make it such that that formula is now choosing the interfaces, and that also will be saved in the analysis, and you can copy that analysis to a different data set. So you can come up with some creative ways to choose your surfaces in an algorithmic way. One thing to note is if you don't like this behavior where the surfaces are tied to the ISO value, you can detach them, and this is basically the old IVAS3 behavior. If I create a detached ROI, now it pulls these surfaces out to a detached ROI, and so now it's saving these in the analysis as the triangles, as the surface themselves, as the mesh, as opposed to storing in the analysis the algorithm to generate the mesh. So hopefully that is maybe clear. Like when you have surfaces up here, they're algorithmically generated and they're saved that way with the analysis. If you detach them, now it's saving the triangles with the analysis set, and nothing you do up here will change the surfaces that are detached. This is especially handy for spatial ranging, which is actually the next thing that I wanted to show. So let's pull up basically everyone's favorite data set and see if I have the range file on this one. Yes, okay. I don't know if anybody's noticed, I haven't had to choose a range file yet, right? And that's because the range file is actually it's with the APSuite. When you do an acquisition, it stores the ranges you used during the acquisition with the hits file, the raw hits file, and then when you do the reconstruction, you open the wizard. Well, those same ranges are going to be available to you in the wizard, and those peaks are already chosen for you when you're doing your say mask calibration steps. And also, there's real-time calibration now with APSuite, so you're really the voltage and mass, the voltage and bull, yeah, the voltage, the time of flight calibration steps continue are continuously updated when you're doing your run, and those are automatically saved, and really makes the reconstruction process go faster. So I have let's make an isosurface here. So there's copper precipitates in this sample. And should be able to see these again if I turn off my points, get a kind of a clear picture of these precipitates. Let's say those. I'm being told I need to look at my chat. I will answer questions in a little bit. So now that here's a better example of like a lot of interfaces here. So let's say I want to look at only things that are bound, meaning that they have ions inside of them. So that automatically excludes those. And let's say I want to look at things that are only of a certain size. Let's say above 5 nanometers cubed. There we go. And I can create a subgroup from this algorithmic definition of these precipitates. One thing you can also do here is open in a new tab, and this will show you just the ions that are inside of that surface. So if anybody knows anything about this new spatial ranging feature, you'll know that basically you can go for any ROI. I'm going to just do a really quick demo here. I can make a new mass spectrum, and then in this new mass spectrum, I can change the range definitions. Let's say in this cube here, and it's visible in this tab here in this cube. Let's say just for illustration purposes, I don't want any iron at all. All right, I'm going to totally take it out. When I update it, you'll see now that if I look down this pipe, that all the iron has been removed from that cube. Now, for illustration purposes, this is totally useless sort of way to do it. But let's say you had 2 different phases of material, top and bottom of your sample, and you wanted to, you had peaks that would normally overlap in phase 1 and phase 2. Well, in phase 1, you can range a peak a certain way, and then phase 2, you range a peak a different way. You can also do spatial ranging using the surfaces. So I would go to my ISO or my interface group here, create a mass spectrum analysis, and also do some funky stuff like removing iron. Oh, wait, I can't do it. Well, I'm illustrating a point here, and that's that because this surface is defined on a concentration, because this interface group here is defined on a surface that's sort of defined on the concentration values of copper. If I change the ranges, that's going to change this ISO surface just a little slightly, but you run into this infinite loop then where when you change the ranges, it changes the ISO surface, which changes the ranges. And so if you want to do spatial ranging on surfaces, you can. You just have to do the extraction like I was showing you before. So if I detach this ROI, I'm going to actually delete this cube and these and that weirdo spatial range that I did. Now I can create a mass spectrum on this detached surface and do my spatial ranging here in a more sort of normal way, which should be like maybe I'd change the width of the peak or change the type of a peak from something like nickel to whatever nickel overlaps. I'm blanking on at the moment. So you can still do the spatial ranging. It just you have to detach the ROI first. So yeah, it tells you that the ranges are overridden, so it's somewhat obvious. And also coming in 6.1 is a feature that lets you gives you better insight into how the spatial ranging has defined things. So let's see. Get to my Zoom chat here quick. Let's see what's going on. All right, here we go. So let me go back here. First question is from Marcus. What is the volume of an arbitrary isosurface here when there's no guarantee that the surface is watertight? I don't know exactly how that's. I think there is some guarantee of water tightness. I think when the volume is 0, that means we should, like IVS3 had a dash when we didn't actually know what the volume is, and I should probably add that back. Right now, if we don't know the volume, it's 0. Yes, and Peter said maybe it's boxes inside. Yeah, and there's basically you can consider an ion inside of an isosurface even if it has holes based on just looking at the nearest triangle. This is what we do actually. You look at the nearest triangle and you look at you consider the triangle an infinite plane and look at which side of that infinite plane you're on.
Is that generally the containment test that you use?
Say that one more time.
Is that generally the containment test that you use both
Yes.
for the, okay, so the containment test, just an explanation to, I don't know if you've been here before, but this was exactly the discussion we had earlier today. So in IVS, it's obviously identical to what we do in the Atom Probe toolbox.
Okay, thank you for that. Yeah. Yes, and Marcus is right. It's not exactly. Yeah, it's there are other algorithms you can use for containment tests. Yes. All right. That's what I wanted to show with isosurfaces. Let's see. I have another approximately half an hour.
Yeah, pretty much. Yeah.
Okay. All right. Let's see here.
Don't worry, we're not going to cut you off if you go a couple of minutes over.
Oh no, and since I don't have any practical stuff, I wasn't quite sure how long this would go. Anyway, so I showed you how we can do we can visualize ions that are inside. So you can see how the containment test is working, which can be quite helpful if you're not quite sure exactly which ions are going to be used in an analysis of a surface that maybe has holes in it, right? So let's see here. Another feature that's brand new that I wanted to highlight here is this mass data management button here. And that is, do you want to demo the CSharp script interface? Sure. Now you can have custom isotopic ratios. So there's the default one, which is the best known published isotopic ratios that we have now. But if I want something different, I can make a new one. And for a good example would be you have a fib that you're using to make your specimens that has an isotopically pure gallium source. And so when you're looking at your gallium peaks, they're not actually the natural abundance of gallium. Maybe I can say, gallium single peak gallium, and then I can go in here and edit my gallium to be 1 peak instead of 2. So let's say typically if it's going to be the 69 gallium, so instead of 60 for the abundance, it's going to be 100 like this. And I save this. Now I have a new isotopic table that I can use for analyses. So here, if I right-click on my top level here, I can pick, instead of the default, I can pick my single peak gallium. Now when I go to my mass spectrum here, let's I'm going to open this up a bit so you have a better look. And I show my overlay of gallium. Should have One peaks, maybe I have to change it here. I have not tried it. I have not tried this clearly. Let's just re-add it quick. So aspect ratios here, mass spectrum, show the peak overlay. Yeah, doesn't work in this particular view. Let's try ID view. Well, clearly I have to fix a bug there. This is what you get when I'm using totally pre-release software here. We make a note. Play. All right, so yeah, we do have the ability to have different tables here. Dieter wants to see the C# scripting interface. So one thing that I actually have not covered is that when you have custom analyses, you can also have, you can include, if you like, in your custom analysis module, a scripting interface where you can write the C# code directly directly in your analysis UI. So this is a really simple example, and this particular one creates. It doesn't look at the data at all. It just creates a graph, and in this case, it's using. So this, the analysis code that you can't see, that was written by whoever created this, is calling this get value to draw this plot, and I can change this to be something else. So instead of it being the square root of x, I could say it's x times x to get x squared. And if I run it now, this should be a different plot. Instead of being square root, now it's x squared. Hopefully that shows you what you want, Dieter. I hope to have some better examples of ways you can use this scripting interface to do some things that actually interface with the ion data itself, as opposed to just kind of drawing arbitrary charts.
And good documentation. We're all hoping for really good documentation.
I know, right? I personally feel that actually for this type of thing, the best documentation is well-documented examples. So if you have examples that show all the different API features, and it shows you exactly how to use them, and it's commented well, that's one. It's kind of self-healing. So for example, if you change the API, that will break your example code. And if your example code is broken, you know that you have to update. You know that you either broken the API and you don't want to break it, or that you've purposely changed the API and you need to update the example code. Whereas if you have separate documentation, you say it's on the web somewhere, or in a doc file, it's not self-checking and self-fixing like compiled code actually is. So my personal belief is that the documentation should be examples. So that's what I plan to do, is to publish in a Git repository examples for every type of API call that we have, and then give you some ideas of what sort of things you can actually do, as opposed to just kind of blindly documenting it. Also with this .NET code, these things are, if I put a comment on this mass spectrum node class, this is an internal. If I put a comment on this class, it will show up when you hover over it, even if you don't have the source code for this, and that comes along in a. There's a XML file that comes along with the DLL. in this case, this is this IVAS module DLL that this it will have it will automatically show you the comment for that class and parameters even when you hover over it. So that is the plan for the good documentation.
So it didn't completely want to get rid of the IVAS name.
Right. No, it's so this the APSuite is the overarching application, and then the IVAS is a module inside.
It's a module in the APSuite.
Yes,
okay.
Yes, exactly. And I talked kind of annual releases of APSuite. We hope to, and we're trying to figure out how the best way. Like we hope to be able to have interim releases of just the modules inside. So when, if we have new features for IVAS, we don't have to wait full year to give you updates. And part of the reasons for the annual updates is that APSuite also, since it runs the machine and is tightly coupled to the machine, we don't, field service personnel don't want to be bouncing around the world installing new versions of APSuite all the time. But I think that users could certainly install by themselves just individual modules that don't really touch the acquisition side of things. When you touch acquisition side, well, then you're talking about firmware and that sort of stuff. So, and we did just kind of illustrating why it's a module and not built into it's not super tightly coupled to the shell. Let's see here. One thing I wanted to note is that we used, and people may have seen this in 6.0, in APSuite 6.0, this interface you see on the screen right now, this coding interface, what was the main way we had, we were doing scripting. And we found out really quickly that most people don't want to write code in this bare editor. They want to use an IDE to write code. And when we realized that everyone was using the IDE anyway, we decided that, well, we took the focus away from having a built-in code editor inside of IVAS and said, okay, well, use a real code editor outside of IVAS. We don't want to make a fully featured, auto, IntelliSense, meaning, fields and values for you. Like we don't want to write that ourselves, or let Microsoft or anybody else, any IDE that you want to use, Eclipse, for instance, does this just as well as Visual Studio. We didn't want to do that, so that's why we ended up sort of pulling the main part of the scripting out. You can still get to this scripting window. It's just it's kind of self-contained within another module. All right. Yeah. Yiming is telling me I have a file I could use. Hang on just a moment here. Okay. I wanted to show something called pinning, and then I'll go through why it's kind of neat. So let's say I have this analysis, and I really like, this isn't a great example, but let's say I really, this mass spectrum is data that is important to me to find quickly later. If I right click on it and say pin, and then save this analysis, I'm just going to call this, demo. Now when I go to the data navigator, I've already forgotten this, 14.8, and I look at my reconstructions, and I pull up the one I'm looking at here. This mass spectrum will actually be available right in this data navigator, so you don't have to actually open up the full data set at all. So if you have results. It could be you can pin results from your custom modules. So if you have a custom plot, you pin it and you save it. The results that plot will be stored in the analysis, the saved analysis. And then when you're in your data navigator, you can quickly pull up those results without having to visualize the entire data set. So the data navigator, in case people aren't aware, is kind of halfway between the database, what we used to call ISDB, which is kind of the lab management tool. It's where you'd move pucks around and create specimens, and IVAS. So now this navigator bridges the gap where now I can look at all the experiments. This is a training database, so there's not many experiments, but I could look at all the experiments that were done recently and very quickly look at the data. So these are preview plots, but they are live. I can actually zoom in if I need to. I can look at mass spectrum, the detector, and this tab stays selected, so I can arrow up and down through the data sets that I have available and look at the various plots that are available here. This noise history is X'd out because this is an old enough file from 2007. It doesn't actually have a preview for the noise history. So if you ever see that X, know why. But voltage, the whole works. And the same goes for the reconstruction tab. You can get preview data of your reconstruction very quickly rendered in this view without having to open up the files. Mass spectrum, detector, voltage history. If anybody has done if anyone in your group who's attached to the same database has done any analyses, you will see them here, and you can get it gives you a tree preview so you can see what they've been working on. There is a 3D view tab here as well, but this does have to go and look at the file, so it takes a little bit longer, and it also does not use ranges, so it's just using a heat map. This is a feature that I plan to actually save a preview in the APT file, so that this you basically can get a real quick rendering of what your data looks like without having to open it as well from this data navigator view.
And Tim, it'll use the ranges for the reconstruction for that.
Yes. Yeah. So basically, this is the work in progress here. Yeah. And I guess that's maybe a point to make. All the entire application is we kind of consider a work in progress. So like instead of waiting till say the custom analysis feature is totally done, totally fully documented, and releasing it, we're releasing it even though the documentation isn't perfect yet, so that we can kind of be a little bit more agile in how we're releasing these features, and hopefully they'll evolve as the releases come out. Right. I wonder if there's anything else that anybody wants to see. If anybody wants to drop it in chat, let me know. Let's see here.
So some of those reconstructions are pretty funky looking. Is that using standard, is it using sort of a bar type, Brian Geiser type protocol, or have you already put in some funky new models?
These are all straight spherical reconstructions that I believe.
So they're spherical voltage-based reconstructions where somebody hasn't spent any time trying to adjust the parameters to optimize things.
Okay.
And in fact, a bunch of these were done with an automated or with a script and a batch of analyses to automatically pull out boron profiles just right down the center, so the exact reconstruction wasn't critical.
Okay.
And that's kind of an interesting point that now with APSuite 6.0, reconstructions are a default reconstruction is automatically created for you at the end of each run. It uses just the straight. So it assumes it only works if you have ranges that you've created in Davis, and if you do have ranges, it will automatically create a default reconstruction for you at the end of your run using the. In fact, you could probably.
Well, and it's generating a live reconstruction for you during the run that you can interact with.
Exactly.
See.
Yeah. It's a demo that I could have pulled off had I thought of it. I can simulate it. Yeah, there is a live 3D view now inside Davis, and let's see. I was going to.
So maybe one question that I can throw in, because we had some metadata and sort of large-scale data analysis thoughts going on in the last session.
Mm-hmm.
Is there any direct way to interact with the metadata database? So we used to have what was the database called in the old days?
ISDB.
The program was called
ISDB. Thank you.
Yeah.
Do we have some way to interact with whatever replaced ISDB, as in sort of it's probably either a MySQL or a NoSQL kind of database? Is there any way that we can go in and just pull stuff out of the database?
Absolutely. It's the same. It's the same database schema as the old days. It just has a different face on it. So.
Okay, so there was a SQL, NoSQL type, right?
It's SQL. It's Microsoft SQL.
Okay.
Yeah. So if you're curious, I can pull it up. So I can.
So you were talking about the new file form. I think it was called APT, right?
Yep. Mm-hmm.
Does that already contain all of the infos that you would have in your database?
It doesn't now, but the plan is to include it as one of the options when you save a reconstruction.
Yeah.
Check a box to say also save the metadata, and that will include all the way, all the data that you could possibly get through a database. That's your project information,
that's very nice.
your experiment details, that sort of stuff. So the database includes. So the old tables are all lowercase, the new tables are all uppercase. It makes it a little easier to find. But so now, not only are we storing, so the old database basically ended at the experiment level. There was no other data that was stored in the database. Now we store information about the reconstruction. We store information about the analysis set, which is the tree, and we store information about the individual analyses as well. And this information about the individual analyses is actually stored as an XML string. So it's I believe. So you can actually see like this isosurface node. If I just cut and paste this into this window here, since it's handy, you can see that here are all it's human readable information about this isosurface. Okay, so you could easily, if you wanted to data mine this for any of your purposes, you're welcome to go into the database and pull out information like this.
That's a great addition. That's really going to be very helpful in the future, I think.
Yeah. And if you, as a paid option, you can also have, not only can you automatically generate reconstructions, you can also generate reconstructions, you can also generate analyses. So if you wanted to run your custom analysis on like automatically at the end of every run, you can do that with an option that does not come with a free one, but I guess I'm putting my sales hat on here. I should have promised no sales talk in this meeting.
No, there's nothing wrong with it. I think you got that wrong. It's not supposed to be an open source software school. It's supposed to be a software school. It just happened to
Sure.
be that most code was open source because it came from the community.
Sure, absolutely. Let's see here. So this is another feature that maybe you haven't seen, which is you can pull out this ion tile window where you can see each individual ion type as a separate chart that's synchronized, and it follows the visibility of your ions. So like if I pull out what your everyone's favorite, the ion control, this tile view follows that. I forget this feature exists because it's been there so long, but if you haven't seen APSuite,
I swear to God, we did not steal it from you. I swear to God, I came with it. I came up with it myself.
We also have a brand new export format. So we're not exporting VRML anymore. We've moved to a new format, GLTF, which I haven't actually tried yet. Should we try it?
It's a high risky demo in the middle of.
I know, right? It's like I said, brand new software. So GLTF is so there's sort of there's a new standard or a newer standard for this sort of arbitrary 3D data. And if I save this, that went pretty fast, and I open up the file. So this is on our network drive, and there's two files here. One is a web page that I can open. Let's say, open this with like Chrome. Loading assets from a file system is not allowed. And that's a newer thing where browsers are not allowed to open up files. So I knew that, but this file here is visible in like a lot of native 3D viewers. This is the one that comes with Windows, and so the axes are there, but the points are not. So I know that I've seen this working on Windows before, so I'm not sure what's wrong with my particular Windows 3D viewer that it doesn't see this. But
don't worry. When Elon Musk wanted to showcase how tough his Cybertruck is, he smashed in the window as well, right? So that's what happens when you do untested things.
Yes, but so this is the replacement for VRML. You don't need a plugin to view it. You can view it directly from a browser without a plugin. It just uses a little bit of the JavaScript. So if I were to put if I had a web server and I dropped these two files on my web server and I browsed this, it would work. It just there's like a weird local policy where you can't load a local file. So.
My teacher gave it.
Someone's doing virtual school like I am here.
Yes, don't worry. We have ways to silence people.
Yes, my children fortunately haven't interrupted today. They often do. So I guess I have just a couple minutes left. Is there anything else?
No, anything you want to ask? Maybe you've got a lot of people here that you might want to ask something. It's also a very good chance to do
that. I guess I wasn't prepared for that.
Which is fair enough, right?
Well, sure, I guess right. I would have a question, Peter and Marcus and Andrew and anyone else. I mean, what do you want to see from us in terms of this type of interoperability? Or I mean, you're developing your tools now, and we're a little behind, I'd say, in where we'd like to be, but we're moving in that direction. What can we do to help speed up a adoption or make it worth the effort of making things working with APSuite rather than just continuing entirely separately.
And well, maybe I'll start with a comment there, and Markus will probably have his own thoughts on that. I think what the most important thing for us is with the CAMECA side is consistency. So I think you've made a lot of data already accessible. Of course, what you can and cannot make accessible is very often a business decision and an engineering decision, of what, how much insight you want people to have in your detector technology and the like. But I think one thing that's very important for us is especially access to the metadata and access to to as much data as possible and in as consistent way as possible. Because what's difficult for us is that if we have to, if you have to change our approach on a fairly regular basis. And I think with the APT file format, which contains a lot of data, especially it would be nice if you could provide a reference implementation for a Python and a MATLAB loader, to load it into NumPy and to load it into MATLAB. That would be something very nice. Maybe I can help you with that, at least on the MATLAB side. Apart from that, I think you've made quite a few steps in the absolutely right direction. Markus, I saw you've switched on your microphone. What are your thoughts on that?
Yeah, first of all, I think it went extremely far and extremely useful for the community. So, I mean, I'm not an experimentalist, that I have to say. So I cannot even say that. But what I see from what the scientists report, at least at MPIE, and the old iOS versions, and what I see now also being seen in these tutorials and what you showed, Tim, that is exactly the way in the right direction. We 100% understand that there are commercial interests, that certain things need to be proprietary, and that is okay. Let me put it. Let me try to put not too much my personal perception here, but what I is in fact get as feedback from the scientists, in particular with respect to the data science and fair initiatives happening in Europe and elsewhere. What I see implemented here in iOS is essentially a very sophisticated workflow from the equation involving proprietary equipment, detector systems, analysis, measurement and analysis. And of course, people would, several people would say, okay, but we want to have everything open. Some people would get insights into the detector technology. Some people would get insight into the details of the post-processing side, like well, how is the ISO service computed and all the like. And you might always argue that with respect to FAIR, we should document data as complete as possible. And in that, typically you will have people who say, oh, but well, what is read raw data and what is processed data different from raw data? I think what is shown here in your talk is that as a proprietor, as a company, there's much initiative, really much appreciated initiative, that now so much things are becoming open. In particular, that there is now unrestricted access, obviously, to the database. If we can start parsing database with respect to metadata. So as a data scientist, I would rather tend now to ask, okay, if we partition the entire life of an Edinburgh specimen up to its role in a publication into different stages, like the proprietary side of a company, the detector, measurement, and post-processing and analysis. What I think would be most useful for the community is to define clearly what and communicate clearly what should remain proprietary and what is post-processing from a numerical point of view, and that should be made, if possible, as open as possible. I don't know what really is the way of going here, because as soon as this initiative that Peter sketched out and people start parsing over thousands of data sets, it will happen that people start to ask questions about uncertainty. And that is one of the key issues that swirls around at the moment through the material science community, in particular motivated by ab initio, but now also permeating whatever research initiative on data science and in FAIR you ask. They always bring up this idea about ontologies, and they bring up this idea about uncertainty quantification. And if we're strict, at some point in 2 years or 3 years, we will start discussing about, okay, well, what is the uncertainty of these data? And then eventually people will start discussing about implementations. And they need to discuss about implementation, how certain things like ISO services are implemented, because it's essentially telling that is one of the building blocks to come up with absolute precision and error margins. I think there's no way around that. But there's always this conflict, and how to resolve this best. I would say what would help the community most is documentation, examples, making these examples open as best as possible, and making interfaces open. For instance, even if now this workflow that is within APSuite 6 would be just annotated with the metadata, and if there would just be a convenience function or convenience button in the menu of APSuite where you can say, tag my analysis and workflow ready for publication as a supplementary piece of information. Something which is open, then people could pass this information and supplement it alongside the hash data set on a repository. That will never be complete. And I think it's also not so problematic it's complete, but it will be much more documented than it is right now, where you just have basically a set of figures, a paper in a journal that most often I cannot even any longer read, and data sets that I don't have access to, or most of us don't have access to. And I think if we go step by step and incrementally, I think this would be most useful for the community.
Looks like a nice reconstruction that you've got running there. Yes, so with that, actually, I would like to thank Tim and actually all of the external speakers and also Martina for their presentations. I think it was a really interesting Atom Probe school, and it was obviously our first one that ran online. And so I only have 2 things to say. The first thing is that actually I think Valentin will send all of you an email with a link to a small questionnaire, and we just want to know how you liked it and what your suggestions would be, maybe for future installations of the whole thing. So yeah, if you've got opinions on that, please go there and let us know. And the last thing I want to do is I actually would like to take a, usually we take a group photo, but right now that's not really possible. So it would be really nice if every one of you could just